something.
Purification. This is essentially
Need a file.
Oh, good.
what do you need?
Oh, I need a sharp pencil or something.
I have a pen. Oh,
Oh,
That's what I was worried about.
yeah. Okay.
oh, wow.
Oh, we waited too long.
Because,
It's gonna be clean before it ever comes out of the reactor.
Wow.
Usually we get the opportunity to see it, but it'll clean up some more before we're done.
Okay, sure. So all the dirts will sink.
settle.
They will either sink or they'll rise.
Okay.
And the reason they're rising is because we're also creating a little bit of hydrogen and they float up.
Okay.
But this reaction, I treated it hard enough that you can already see that it's going to clean up almost instantly. So let's talk about what we're doing, and then I'll answer your question also. What we're doing is, there's good news and bad news about it. People have been trying to do what we're calling, this is the technology, We don't- electrocoagulation. We don't need any chemicals, but what we're doing is we're putting a inert electrode in the water. That's our cathode. We're putting an active anode in the water, and that's our anode. This is our anode here. Our cathode is here.
Plus minus.
I got to spell it right. Still misspelled it.
H, yeah. H-O.
I'll get there in a minute.
That's okay.
And then what we do is we very simply hook a battery across like this, okay? And when we do that, we drive pure aluminum into the water, but it's highly charged now. The aluminum metal has lost 3 electrons, which really make it active. That's exact, and so it really oxidizes easily. That's the reason aluminum is shiny on a building, because the surface is highly oxidized with aluminum oxide. And it does it so quickly that the aluminum stays shiny and never oxidizes anymore. And the reason it is that aluminum oxide is super hard. And and that's important, I'll tell you why in just a minute. But at any rate, no matter what's in the water, with the exception of salt, this reacts, creates a chemical compound, and it does one of two things. It either settles out or it rises to the top, okay? And so you wind up with a precipitate down here that's completely inert. You can put it in a landfill with no trouble at all. It'll go in a landfill, and typically what you see when you do this little silly test is you see it fall to the bottom. Well, what you can also do is you wait just a minute and then you can filter it. So typically in a continuous run situation, you will do the water, you'll let it go into a flocculation tank for just a few minutes, and then you'll filter. And that's how you run the operation. Okay? Well, what's interesting about this is that people have known about this since about 1883. And there are more than 500 scientific papers really explaining the science. So we really understand the science. And we know, and we're beginning to develop ways to really predict what waters we can treat, what waters we can't treat, and so forth. But if you want really clean fresh water or really clean salt water, this is a great way to do it. Okay? And all we are,
Salt water, the ocean water?
ocean water will be clean, but it won't be without salt.
desalinated.
Oh,
It'll still have salt.
So you can't drink it.
However,
You'd have to go through a desalination process.
you can't really run a desalinization process in the way we do it today, which is typically reverse osmosis or capacitive deionization. Both of those have a membrane associated with them. And if you don't clean all this junk out of the water ahead of time, then in fact, you will destroy your membranes. So what this is a pre-process for anybody that wants to do desalinization by reverse osmosis. And it works really well for that. And in fact, this particular water, to your question, this is produced oil water. And produced oil water for every gallon of gasoline that we make in this country, or for every barrel of oil that we pump, we get 4 gallons of that kind of dirty looking water.
Wow.
That today,
And what do they do with it?
we pump, today there are 200,000 deep disposal wells in the US. We get rid of 1.2 billion gallons per day down these deep disposal wells.
Is this kind of water good for your farmlands?
Pardon?
Would this water be good for your farmland? Or
No,
it
but it would be
kill
fine for
farmland?
agriculture. And it would be fine for feeding animals. There's no place, there's no state that allows us to reprocess this water for drinking. But if you put
But I mean for growing vegetables.
vegetables, be fine.
So
It doesn't have anything in it.
No, so we could,
We
why
remove-
aren't we using that why aren't we giving it when we have droughts? Why isn't this water being sent?
Because we've never had enough droughts, for one thing.
Yeah,
But
well,
the
I
people in
With-
California
well, we-
could have used it.
Well, they